Good morning, friends. Today we'll be discussing about theory of machining, and we'll be going to cover the topics: overview of machining technology, the different types of chips. These chapters are part of your tool engineering subject for 5th semester mechanical engineering. In material removal processes, we will be going to discuss which are the different machining parameters, which are the abrasive processes, which are the different non-traditional processes. What is metal removal processes? It is a family of machining shaping operations where the material is removed. Undesirable material is removed by sharp cutting tool. In case of machining, in case of abrasive processes, it is removed with the help of abrasive particles like grinding, honing. So these are all different abrasive processes. In non-traditional processes, we use different forms of energy like mechanical, chemical or thermal energy to remove the material. Here there is no cutting tool used. As you can see in the slide, metal removal processes are basically classified as conventional, abrasive processes and non-traditional machining. Conventional machining include turning related operations, drilling related operations like milling or other operations. In abrasive processes, like they include grinding or honing and other abrasive material removal processes. In non-traditional machining, we are using different types of energy like mechanical, chemical, thermal to remove the material. Now, before starting, we will see what is machining. Machining is a process in which the cutting action involves the shear deformation of work material, and the material is removed in the form of a chip. This is done with the help of a cutting tool. The cutting tool can be positive or rake type cutting tools, positive rake type cutting tools or negative rake type cutting tools. As you can see in the picture, the cutting tool penetrates into the workpiece. The cutting tool is subjected to compressive forces. So as soon as the workpiece crosses its elastic limit and proceeds into the plastic limit, the chip shears itself from the region. This shearing occurs in the shear plane. Now we will see why machining is important. A variety of work materials can be machined, and these are mainly used to cut metals. Variety of different shapes having different geometric features are possible, like screw threads, and accurate holes can be drilled with the help of machining. And we can obtain good dimensional accuracy and surface finish. Now these are all the advantages of machining. Now we will see what are the disadvantages of machining. In disadvantages of machining, material is wasted. That is, chips are generated in machining, and it is time consuming. Machining processes are very time consuming, unlike other material forming process where the process takes place in less amount of time. Now we will see which are all the machining operations. Turning, drilling, milling, these are the different machining operations. Shaping, planing and broaching, these are the other machining operations where a multi-point cutting tool is utilized. First we will see what is turning. In turning, a single point cutting tool removes a material from the rotating workpiece to form a cylindrical shape. So this, I think, as part of your workshop practice, you have already done the turning operation. Now we'll see what is drilling. Drilling is used to create a round hole by means of a rotating tool, which is also called as a drill bit. This drill bit has two cutting edges. As you can see in the picture, the tool is given a downward motion into the workpiece. Milling utilizes multi-point cutting tools. Here the rotating multi-edge tool is moved across the work to cut in a plane or a straight face. There are basically two types of milling: peripheral milling and face milling. All machining operations require a cutting tool. Cutting tools are basically classified as single point cutting tools and multi-point cutting tools. What are single point cutting tools? They have one dominant cutting edge. The tool point is usually rounded off to form a nose radius. And in multi-point cutting tools, these have more than one cutting edge. Drill bit has two cutting edges. Milling cutter has multiple cutting edges depending on the number of teeth. Now we'll see which are the four basic types of chips. As you all know, in machining, chips are generated. These chips can be classified as discontinuous chip, continuous chip, and chips with built-up edge, and lastly a serrated chip. We will see one by one what is discontinuous chip. Discontinuous chip mainly occurs in brittle materials with low cutting speeds. Here the feed is large and the depth of cut is higher. In discontinuous chip, the chip tool friction is very high. In continuous chip, this is mainly done for ductile materials having high cutting speeds. The feeds are very small and the depth of cut is larger. And next we will see continuous chip with built-up edge. This is mainly done for ductile materials having low to medium cutting speeds. Tool chip friction causes the portion of the chip to adhere to the rake face. This is called as a built-up edge. The built-up edge continuously forms and breaks off cyclically. Next we will see what is a serrated chip. Semi-continuous chips. These are semi-continuous chips having sawtooth appearance. These are also cyclical chips and it is very difficult to machine. It is very difficult to machine these metals at high cutting speeds. Thank you.